Electricity transmission. The U.S. has three interconnected regions. You can see the regions over here on the map to the left. We have the western interconnected region, that's the area in brown. And then the eastern, which is all the colored areas on the eastern part of the dotted line, and then there's Texas. Each interconnection is an independent alternating current grid. A small amount of electricity flows between them on direct current lines. So in the most recent energy crisis in Texas, it's not true that Texas is completely isolated. There are direct current lines, high voltage direct current lines between each of the other interconnected regions. The colors in the eastern area are different ISOs. These are different, so each of the regions in the east are connected, but they may be governed by different entities, different ISOs. FERC regulates the transmission grid. You may have heard of FERC before. It's the Federal Energy Regulatory Commission, which oversees the transmission on the western and eastern interconnection. FERC does not regulate the Texas interconnection. So Texas is on its own. Regulation has evolved over time. Initially, transmission was constructed and owned by regulated utilities in their exclusively controlled territories. Public Utility Regulatory Policies Act of 1978 required regulated utilities to buy electricity generated by small non-utility generators at avoided costs. This basically encouraged small power generation from cogeneration and renewables. In other words, this act increased competition on the grids. The problem, though, was that utilities still owned the transmission lines, and so FERC said they put out an order, and that specified that, one, they must let anyone use their transmission lines. In other words, a utility cannot say, we own this transmission line and you cannot put your electricity on it. And two, they must charge everyone the same rate. So basically, they should not utilize any market power in their transmission. Anyone should have access to the transmission lines. This makes sense because if a utility owned a transmission line and didn't allow anyone else to use it, then if you wanted to build a generating station, even if the wholesale markets were competitive, if the transmission was not, then you couldn't get your electricity to the grid. You'd have to build your own transmission lines, which would be terribly inefficient. Many entities are involved in the decision to build electricity transmission. Some utilities specialize in building transmission. Regional transmission operators, or RTOs. They are independent and not-for-profit. They are very similar to the ISOs we've talked about, but they run the transmission lines. They're basically coordinating transmission, which is actually a really complicated job because there's capacity constraints on the transmission lines that the transmission operators have to deal with. Then there's FERC, which gets involved in deciding when new transmission is built and in the regulation of transmission lines. And then there's individual states deciding how much transition to create. There's many obstacles to inter-regional transmission projects. There's the not in my backyard problem. Mainly people don't like transmission lines where they can see them. You also have to maybe get leases to put them on public lands, or you have to go through private lands and you pay the landowners to allow you to put a transmission line on their land. There's more than one state agency controlling project siting, so you have to go through a lot of bureaucracy. There's distributional impacts. The regulators required to protect consumers in their state. The capital investments is financed by the consumers through the increased retail prices. So there's pushback to that from state policymakers. So it's difficult to create new transmission line. New transmission projects create winners and losers. Transmission projects connect a higher price area with a lower price area. Wyoming and Colorado are a good example of this. Wyoming has a lot of cheap wind power, and Colorado has relatively more expensive power. And so Wyoming would like to get its cheap power onto the Colorado grid, and so they want to build transmission lines going from Wyoming to Colorado. The winners are consumers in high-priced areas, producers in low-priced areas, like the wind producers in Wyoming. The losers are the producers in the high-priced areas because you have new competitive generation that's cheaper coming online, and consumers in low-priced areas because some of their cheap power is being exported out of the state. And there's the average price per megawatt hour falls, but gains may not cover the cost of building transmission. So those transmission costs are then going to be passed on to the consumers. FERC tries to encourage efficient investment. The firms make investments if the present value of future profits exceeds upfront capital costs, just like before in the investments in generation capacity. Same with transmission. But transmission is a regulated monopoly, and regulators want to set rates such that the present value of the future profits is high enough to encourage investment. So regulators are passing those costs on to consumers, and they're doing it in such a way that it's high enough that it encourages transmission investment, and utilities build transmission where it is needed most. So they want to encourage transmission in places that's actually needed. Where are the places that it's actually needed? So here, this map shows differences in locational marginal pricing. They're one way to determine where transmission would be most beneficial. Locational marginal prices are the prices for electricity at different nodes on the electricity grid. So node is a place where transmission lines come together. They're the cost to serve an additional megawatt of electricity demand at each location. So this map here shows the regional or locational electricity prices for the eastern United States. And you can see going further east to the population centers where there's higher demand, the locational marginal prices are increasing because there are transmission capacity constraints. In other words, they're trying to force a lot of electricity into that area with not enough transmission capacity, and so you get capacity constraints or congestion on the transmission lines, which increase these local marginal prices. Where there is less demand and less capacity constraints, the prices are lower. That's out west. These transmission constraints cause problems, as we just saw. There's higher regional prices that lead to higher revenue for transmission owners. This is a disincentive to build more transmission. Why would you build more transmission if you can charge higher prices when you don't build more transmission? The investors consider the impact of their investments on locational marginal prices, just like a monopolist considers its impact on the price. So they're thinking of whether or not to build additional transmission in the sense that with respect to if they build more transmission, they're going to decrease the local marginal prices, and actually they're reducing their own revenue by doing that. And thus regulation is needed to smooth the transmission markets. So readings for the next section: Market Impacts of a Nuclear Power Plant Closure by Lucas Davis and Katie Hausman. We're going to talk about market integration and the consequences of a nuclear power plant shutdown.